Hello, this is Tom English, and our topic for this lesson is the system of equations. And basically what we're referring to there is where we have a couple linear equations to solve, and that's basically, if you think about a linear equation, we know each equation represents a straight line. And so when we think about the system of, or the solution for a pair of equations, we're looking for where those lines intersect. One way to solve the equation would be to actually graph each line, put it into its form of slope intercept form, and solve the equation. But I don't recommend that, only because the chance of the intersection point being on a grid that will be a whole number for x and a whole number for y is very remote. And if you can imagine trying to estimate the value of x and y on a graph, I don't care how good your graph is and how detailed the paper and so forth, very difficult to do. But if you're looking at approximations, that's definitely one way of doing it. Rather than waste time with that, though, I'd like to jump right into another way of doing it, which is substituting. And that's where we find a value for one of the variables in one equation and then substitute that into the other equation and solve for the second variable. Let's start with the system of equations that I have up here. One equation being 2x plus y is equal to 4, and the second equation is 3x minus 2y is equal to a negative 1. Now, I admit right up front I chose these so that I'd come out with nice even numbers, but don't expect that to happen to all the problems that you work on. Usually the solutions tend to be mixed numbers, fractions, decimals, so forth. Very seldom do you get a nice round whole numbers. But one of the things, by substituting, what I'm suggesting, if you look at both of these equations, and is there one that will allow you to solve for x or y more easily than the others? And so one of the first things you should look for is any of the variables with a coefficient of 1. And I hope you see in the first equation the y has a coefficient of 1, and therefore we could easily solve that equation. Let's start again. 2x plus y is equal to 4. If we subtract 2x from both sides, then we've already solved, then we know that y is equal to a negative 2x plus 4. By solving for y, we can then substitute that value right back into the second equation, and we now have 3x minus 2 times, and here's our value that we're substituting in, minus 2x plus 4 is equal to negative 1. Now if we solve this, distribute the negative 2, we now have 3x, negative 2 times negative 2 is a plus 4x, negative 2 times plus 4 is negative 8, is equal to a negative 1. Combine like terms, we have 7x minus 8 is equal to minus 1. Add 8 to both sides, and we get a very convenient 7x is equal to 7, x is equal to 1. Now, we take that 1 and we can put that back into either equation and find out the corresponding value for y. Let's substitute it back into the first equation. We have 2x plus y is equal to 4. x being 1, this becomes 2 plus y is equal to 4. And to solve for y, we subtract 2 from both sides, and we get an answer of y is equal to 2. So our set of the values would be x is 1, y is 2. Can we be sure that's the right answer? Well, let's take those values, substitute it back into the second equation, and see if we have a good solution. 3 times x, and we said x is equal to 1, minus 2 times y, and we said y was equal to 2. Is that equal to a negative 1? Well, we get 3. Negative 2 times 2 is negative 4. Is 3 minus 4 equal to minus 1? Yes, it is. Minus 1 is equal to minus 1. So it checks. So this is a form of substitution. It was easy to find an example where we had a coefficient of 1, so we just picked that one. That was the easy one. If we don't have anything that simple, one of the things we can do is add or subtract the equations and see how we can eliminate. For instance, let's look at the original equations again. And what would we have to do to one or two of the equations to get something to drop out? For instance, if we multiplied that first equation by 2, we would end up with a 2y in the top and a 2y in the second equation. Since one is positive and the other is negative, if we added those two equations together, then we're going to see that the y's drop out. We'll have x is equal to, solve for x, substitute it back in, solve for y. So that is called adding or subtracting. But let's first multiply this first equation by 2. So that has to be 2 times 2x plus 2 times y is equal to 2 times 4. We haven't changed the value. As long as we're multiplying through each term by 2, the value remains the same. But what do we have now? We've got 4x plus 2y is equal to 8. Bring down the second equation. And I hope you see now that we have positive 2y and a negative 2y. So in this case, we can just add these two equations, and what do we get? 7x, the y's drop out, is equal to 7. X obviously then is equal to 1. Okay, we know that matched the last one, so we know that was good. Another way we could do this is to actually, let's say we didn't pick up on the y's right away, and we decided to eliminate the x's. Well, how would we get the x's to be equal to each other? Well, if we multiplied the first equation by 3, we'd have 6x, wouldn't we? If we multiplied the second equation by 2, we would also have 6x. Then we could subtract one equation from the other, and the x's would drop out. Let's try that one. 3 times 2x is 6x, plus 3y is equal to 3 times 4 is 12. 2 times 3x is 6x. 2 times negative 2 is negative 4. Y. 2 times negative 1 is negative 2. Now, these are both positive, so what are we going to have to do? We're going to have to subtract one from the other. Typically, we always subtract the lower one from the upper one, but it doesn't really matter, but let's do that. Let's subtract this equation. We subtract that, the x's go away, But now this is a positive 3. We're subtracting a negative, so that becomes a positive 4. So that becomes 7y. Negative 2, we're subtracting a negative 2, so that becomes a positive 2. That's equal to 14. 7y is equal to 14. Y is equal to 2. And if you'll recall, that is the answer that we found the first couple times. So, 3 different ways that we can do this other than the grafting. The main thing is to find a value for one of the 2 variables, substitute it in to the original equations. And the one thing I want to emphasize again is always check your answers. If this was the first one we found, we said y is equal to 2, let's put it back into, and always put it back into the original equations, because you might have made a mistake in converting. So to be really certain, you want to go back into the first equation. So if we substitute 2 in for y, we have now 2x plus 2 is equal to 4. Subtract 2 from both sides. We have 2x is equal to 2. X is equal to 1. If x is 1 and y is 2, let's put that into the second original equation. We have 3 times 1 minus 2 times y was 2. Is that equal to negative 1? Well, this becomes 3 minus 4 is equal to minus 1. Minus 1 is equal to minus 1. The world is all right. Check. Hopefully that shows you how to solve a system of equations. There's more than one way to solve it, and hopefully working on some of these. Again, I emphasize though, most of your answers aren't going to be as convenient as 1 and 2. You're going to end up with questions or answers like x is equal to 25 over 11 and y is equal to 13 over 11. Those kind of answers, you might have x is equal to 5.666. Don't be surprised when you see that, but again, don't just accept it, put it back in to the original equations and see that everything checks. Thank you.